Look at this problem 921, minimum add to make parentheses valid, medium difficulty. Parentheses string is valid if and only if it's an empty string. It can be written as A, B, where A and B are valid strings, or it can be written as parentheses A, parentheses, where A is a valid string. So you're given a parentheses string S. In one move, you can insert a parentheses at any position of the string. So for example, if you're given this, you can insert an opening parentheses to be here, or a closing parentheses to be here. Return a minimum number of moves required to make S valid. So here it's 1 because you just got to remove this right parentheses. Here it's 3 because you got to remove the 3 left parentheses. Okay, so basically, so what are the conditions for when a string would be invalid? So let's say you had like parentheses, some random characters, S, and then like an extra parentheses here, an extra left parentheses here, and then some other characters. So in this case, if you go here, you got left parentheses, so we'll call this like L or something. That's okay. We hit a right one here. This is where we can't just add it automatically. We have to first check if there's a left parentheses, in which case there is. So let's just say like this is L equals 1. So here, because L greater than 0, this R is okay. And then you would also remove like, or you just say like L minus equal to 1. So then now when you hit this left parentheses here, whoops, let's add this as another line. So let's see, hit another left parentheses here. Because L is 0, that implies this R is invalid. So you need to remove it. So if you have like another variable, let's call it like remove. It's basically keeps track of how many number of moves we need to make S valid. So here you would make remove plus equals to 1. Then we go to this left parentheses here, and then now L plus equals to 1. And then all these other characters here are okay because they're not parentheses. So then basically at the end we would have L is 1, R is 1. So basically whenever R is greater than 0, we know the removed must be plus equals to 1. So here L equals 0 implies, so then we would do like R plus equals to 1. We could do that instead of this remove. It's basically the same thing. Here we don't increase R. Here we increase L. So basically this left parentheses is invalid and this right one's invalid. So then that's why the L is 1, R is 1. So basically it would just be return L plus R. Right, so we can work this example here just to make sure this logic is correct. So here we got L equals 1. Here L greater than 0 implies L less than or equal to 1. Here L equals 0, so it implies R plus equals to 1. So return L plus R, which would be 0 plus 1, which is 1. So that makes sense because we just had this one parentheses to remove. And in this last example here, so here we got L plus equals to 1. Same thing here, and then same thing here. So then basically at the end, we're going to have L equals 3. So return L plus R, which is 3 plus 0, which is 3. And that matches this 3 in the output here. So it looks like we got the logic for the code, and we just need to code it now. So for I in range length of S, so we're going to have L and R equals 0 and 0. So let's see, we got left parentheses. Okay, so if S of I equals the left parentheses, then we're just going to do L plus equals to 1. L if S of I equals a right parentheses, then see, so check if L is greater than 0. If it is, then you decrease L. If L greater than 0, L minus equals to 1, else, then, so here L is 0. Yeah, L is 0, so R plus equals to 1. And then you just return L plus R. All the other non-parentheses characters are irrelevant. So we got here L plus equals to 1. Here L is greater than 0, so then L minus equals to 1. And here L is 0, so R plus equals to 1. So it looks like that's it, and we could just run this. And it passes all test cases. So that's it. Thanks for